given h of p equals the cube root of the rational function 3p over p plus 5. Now notice that this is a really tall cube root, and the entire fraction is under the cube root. I want to make it really clear the entire fraction is under the cube root. Find part A, B, and C, h of 3, h of 4, and h of negative 1. Okay, let's look at part A. H of 3, just substituted in cube root of 3 times 3 over 3 plus 5. So it's a cube root of 9 over 8. Now bust this up on the top and bottom. Cube root of 9 over cube root of 8. All right, now we have to get the radical out of the bottom. Well, you know, it so happens that the cube root of 8 is a simple number too, because 8 is the same as 2 raised to the third power, right? So 8 was a perfect cube. It was really easy to get the radical out of the bottom. It just came out by itself. Now let's go to part B. Part B is h of 4. Just plug that in, cube root of 3 times 4 over 4 plus 5 equals the cube root of 12 over 9. Now bust this up on the top and the bottom. Cube root of 12 over the cube root of 9. And now I'm going, what's the problem with this? Well, it has a radical in the bottom. I need to get it out. In other words, I need to rationalize the denominator. Now, this is going to take a little thinking. It's not as easy as getting the radical out of a square root. I have to get the radical out of the bottom when I have a cube root here. So I have to make the stuff underneath on the bottom of this fraction, I have to make the stuff, make it into something that's cubed so I can cancel the third power with the third root. So here, let me think about it. Let me think about it in writing here. Currently, on the bottom, I have the cube root of 9. Now, let me factor the 9 down just to look at it closely. Okay, so I've got the cube root of 3 times 3. Now, if I had one more factor of 3 under that radical, I would have a perfect cube, right? I would have base 3 raised to the third power, and then the third power would cancel with the third root, and I could get rid of the radical. So this is what we want. We want to have the cube root of 3 times another 3, and then we could write it as a cube root of 3 to the third, and the third power and 3 could cancel, and we would just get the number 3 without the radical, the base number. So we're going to have to change what we have to get that extra factor of 3 under the radical in the denominator. So we have the cube root of 12 over the cube root of 9. Okay, well that's equal to itself, cube root of 12. All right, I'm breaking down the 9. I'm just breaking down the 9 as 3 times 3. Now I'm going to do something to get an extra factor of 3 down there. So I have 3 times the cube root of 12 over 3 times, the cube root of 12 over the cube root of 3 times 3. Now I'm going to multiply the top and bottom by the cube root of 3. Now, why did I choose the cube root of 3 with the cube root symbol? Now I can do the multiplication on the bottom under a single radical sign because they have the same index. And I'll get what I want on the bottom. Of course, I have to do the same thing on the top because I'm multiplying actually the entire fraction by 1. So I have to have the same thing on the top of my fraction and the bottom. Cube root of 3 over cube root of 3. So now I'm happy because this is going to give me on the bottom what I'm hoping to get. So on the top I can do the multiplication under a single radical also because they're both cube roots. They both have index 3 in the hook, so I can multiply them together. On the bottom, I get what I've been searching for, the cube root of 3 times 3 times 3. Now on the top, I've got 12 times 3 under the radical, so that's the cube root of 36. And on the bottom, I've got my cube root of 3 cubed, and I can cancel my third power and my third root and get rid of the radical on the bottom. And now I'm very happy because I have cube root of 36 on the top and just a 3 on the bottom. And now, of course, I should have asked myself, can I factor a perfect cube out of 36? Let me think about this. What are perfect cubes? Let's see. 1 is a perfect cube. Let's see. 2 times 2. 8 is a perfect cube. Is there an 8 in 36? Let's see. No, there's no 8 in 36. And the next perfect cube would be 27. So, no, there's no perfect cube factor in 36. So that thing simplified on top, and we got rid of the radical on the bottom, so we're cool, and we are finished. Happy face. Okay, let's continue. The last part, C, we're going to evaluate h of -1. Plug that into the radical, the cube root of 3 times -1 over -1 plus 5 equals the cube root of -3 over +4. Now bust this up top and bottom. Cube root of -3 over cube root of 4. Let's see, I can pull a factor of cube root of -1 out in the front, on the top. Okay, so you see what I did? I factored -1 times 3, and then I factored out the cube root of -1, which, by the way, is just equal to -1. It'll just be a negative sign in the front when I'm finished. Now on the bottom, I've got the same situation I had in part B. I'm going to factor the 4 as the cube root of 2 times 2, and then I realize, hey, I just need another factor of 2 down there, and I'll be able to rationalize my denominator. So I've got -1 multiplying the top, and I've got the cube root of 2 times 2. Now, here I am trying to get rid of the radical in the bottom, multiplying the bottom by the cube root of 2. See, that's going to give you my extra factor of 2 under the radical downstairs, and that'll help. And then the top has to be the same thing because I'm multiplying by a fancy form of 1. Okay, so up on top, the -1 that's multiplying in the front, that's just a negative sign in front. Negative. Oh, first let's work on the bottom. Cube root of 2 cubed cancels. On the top, we got negative cube root of 3 times 2. Okay, what happened 3 times 2? I was able to do the multiplication under a single radical sign. The cube root of 3 times the cube root of 2 is the cube root of 3 times 2. So my final answer is negative cube root of 6 over 2. So I got the radical out of the bottom, and 6 has no perfect cube embedded in it. There's no way I can factor out a perfect cube from 6, so there's no simplifying the top, and we are finished.